All right, thank you. All right, hello everyone. If I haven't yet met you at this conference or conferences in the past, my name is Jahr. I am the founder of Vue Mastery. And if you're not familiar with our platform, we are the ultimate learning platform for Vue developers. So we have a whole collection of courses that teach you a bunch of different topics throughout the Vue ecosystem, so you can elevate your code, advance your career, and level up your team together with our team accounts or personal accounts that give you access to our entire course library. So today's talk, we are going to be focusing on taking a journey deep into the Vue ecosystem, specifically to the wonderful world of Pinia. So as I'm sure you're mostly aware so far, Pinia is a lighter weight, more modular, less prescriptive, more freeing version of state management, excuse me, that's really a next evolution beyond Vuex. And so with that additional freedom that we have, as the old adage goes, with great freedom comes great responsibility. And the reason we have that responsibility is because we have more options to be creative, for better or worse, in how we conduct that state management in our applications. So instead of accidentally implementing some anti-patterns that we will regret, this talk is going to focus on how we can use that creativity to add excellence into our app so we can build things that will serve us now and into the future as well. So we're going to focus on some proven Pinia patterns that have been approved by Posva Eduardo himself, so you can rest assured that these are production ready. All right, so specifically, we're going to look at organizing our Pinia stores and how to accomplish that. We will also take a look at options versus setup stores, the limitations and advantages of either or and why you might want to use either. We'll also look at different ways we can be accessing and updating our state. And we'll look at some unique Pinia features such as the patch and reset methods. In order to kind of have a playground to apply these concepts to, we're going to be looking at this example app. So I'll just give you a brief tour of how it functions. As you can see, we have this input here, and really what we're doing is we're putting in a location and then searching for restaurants of type, maybe burger, pizza, sushi, and whatnot. So we get results here. We have an authentication system, so you can add a restaurant to your favorites. And then we're using the Google Maps API to gather more details about the specific restaurant. So, of course, this is a Pinia talk, so the app is tracking state for each logical concern within different Pinia stores. So we'll unpack that as we go. So, but before we dive deeper into Pinia, let's get clear on why you'd want to use it in the first place, especially considering with Vue 3's composition API, we already have a built-in reactivity system that allows us to flexibly share state. So with just using the composition API, we could create a reactive object, import reactive, and then create a store. And we could use this to manage our global state, where every component that then imports that store could have access to the state. And run methods to increment it, etc. And then, of course, each component that depends on that state and is maybe using it in its view would then, because of the reactivity system, update automatically when those store values are changing. So again, we have a kind of built-in reactivity system that allows us to accomplish this store behavior. So at what point, kind of what lines would we be crossing when we would want to be using Pinia specifically? So you'd want to consider Pinia if you want to introduce patterns for collaborative organization across your teams, so you have kind of some standards and procedures to handle your state and the management thereof. Also, with the Pinia library, we have the actions that we can use to mutate our state, which gives us some predictability and some kind of repetitive ways to mutate. And then we also have SSR security built in. So if your app is using server-side rendering, you'll need to be careful with how you manage global state, since SSR apps, they initialize the app models on the server and then share state across every request, which could lead to security vulnerabilities. But Pinia was designed to make it easier and safer to manage that state in the server-side rendered apps. And also, kind of all of these combined, plus some other intuitive features within Pinia, means that we have a great dev tools, debugging experience. We get great transparency into how things are happening within our app, whether we're looking inside of the stores or we're looking at the timeline of events that have occurred and the list of mutations associated with them. And if you're a TypeScript user, which I'm sure increasingly more and more of you are, with Pinia, we have first-class TypeScript support. So that's, of course, very important to many developers. And yeah, and then we have a great developer experience because of all of these features. So all these reasons combined mean that Pinia empowers us with a robust and refined way, really, to architect our app's infrastructure as it relates to state management. So now that we're clear on the point at which we'd want to integrate Pinia into our projects, we can start to explore some of its features and the nuance of how to work with it. So I mentioned earlier there's a couple different ways we can compose our stores. There's the options version and the setup version, which is the setup's going to rely on the setup method. And I would want to preface this section with there's really no right or wrong answer. Whether you use an option store or a setup store, there's going to be limitations and advantages for either, and we're going to look at a bit of those. Now, when we're defining a store, either way, we would want to be importing the define store method from Pinia, and then when we're defining that store, we're passing in really the ID for that store. In this case, we're giving it an ID of auth. And this ID, we need it to be unique because Pinia is going to use that to track the state for each store, which it uses in the dev tools, and it also is going to use it in plugins as well. So for example, if you are building a plugin to extend the API features of Pinia, and you don't want maybe that plugin to apply to every single store, and you just want it to apply to a single store, you could use this store ID to achieve that. Now, the differences come in when we're actually defining the store in terms of that second parameter here. So with an option store, that, as it sounds, is going to be an options object, which is that second parameter. And we will have our state as a property, our actions as a property, and the getters as well would be a property. So we've essentially got an object for each of these options. And really, if you think about this as an analog to the options API in the components, the state is analogous to the data, actions are analogous to the methods, and then getters would be analogous to computed properties. So comparing that against the setup store, we're importing ref and computed, which we'll see why in just a second. And now the second parameter here, instead of being that options object, it is actually a function. And this is going to be functionally familiar to you if you've been working with the composition API, where here our state is going to be a ref. We could also create this with reactive. And then the action itself is just going to be a function. And then the getter we could achieve with a computed property, which comes with the added benefit that then the values would be cached unless they are recomputed. And then just like the composition API, we do have to return the state actions and getters, everything that we want to be accessible outside of the component. Something that I want to kind of reinforce here is it is called setup, but know that that's more so referring to the setup function of the composition API kind of way of creating components. It's not referring to, for example, the script setup syntax of the composition API, where you wouldn't actually have to return these values, but in this case, you definitely do. All right, so like I said, which should you choose? Again, that's up to you, but I do want to touch on some of those distinctions, and in this case, the advantages that the setup version gives us. So, for example, we can easily use composables inside of our setup stores. Like maybe if we want to use a vue.use composable here, we could pretty simply achieve that. And also we can use watchers as well. So we are actually using both of these in our example app that I showed earlier. So if you notice this behavior here, where if the user doesn't type anything into the city input, their location, their current location will actually be found automatically. And if we look at the code for how we're achieving that, you can see that we are using the use geolocation composable from vue.use. And we're getting the coordinates with that. And then, of course, we're also using this watcher. So here's kind of demonstration of how we can take advantage of those setup store specific features. And when we talk about Pinia, it's important to understand that Pinia is modular, and it's modular by design. So we are encouraged by its very API to be splitting up our state into manageable, kind of more bite-sized, domain-driven pieces that are naturally related to each other. So we'll kind of unpack what that looks like. And this compares, of course, to Vuex, which wasn't inherently modular by design. With Vuex, we had that one root store file, and then we had modules that broke off from that. Conversely, with the Pinia API, we have stores that are devoted to those major logical concerns of our app, and then we can essentially import those stores wherever they're needed. So for example, this auth store might be needed in multiple components. And when it comes to the benefits of this modularity and the way this API is written, it's going to help bundlers with code splitting. It's going to provide better type inference. We're going to have boosted team collaboration if done well and organized well. And then we're going to have additional clarity for our debugging purposes. Now, when it comes to actually putting this modularity and the organization thereof of our stores into practice, it's not always straightforward. Sometimes it's a bit nuanced of how we break it up. So we're first going to look at a more simple example, and then we're going to look at a more complex example. So when we're talking about this, I basically am thinking about the store organization of the application, and doing that in a good way is going to set you up to, again, have all those benefits in terms of collaboration, debuggability, and so forth. So looking back at our example app, we see that a user can register an account, and if they register or if they're already have an account, they log in, we can see that the nav bar is changing based off of that user state. And so to achieve this authentication behavior, we're tracking the user state and the actions related to that, the register, login, and log out actions. So it's pretty obvious here that these can all be grouped together into its own store, and we might call that auth or authentication. And again, that was an example of something that is pretty obvious of how you would achieve that. There's not really complication in that from a kind of cognitive perspective. But let's look, on the other hand, on something that is a little more nuanced. So if you remember here how this is behaving, we have this first input. where you're putting in the location that you want to be searching for restaurants in, and then the second is searching for food, the kinds of restaurants that you'd be searching for, and that second input is helping us return restaurants that are in a certain proximity to the location from the first input. So if we kind of break this apart, functionally, both inputs have event listeners that are triggering separate functions. The city one calls for the latitude and longitude of the input value. And then the search here is calling for the related restaurants, again, within a certain distance of that city. And so they're both relying on and making calls with the Google Maps API. So you might think, okay, so maybe we're supposed to be then creating an API-specific store such as Google Maps, and that's our store, and we're putting all of the Google Maps-related logic and state and whatnot into that same store. But when we look at our project more holistically, we might find that there's actually many actions that are relying on this same API, which would then turn into a lot of code, too much code for one file, again, going against the kind of inherent design and intentions behind the modular approach of Pinia. And more importantly, the actions aren't all related to the same logical concerns. So to piece this apart, we can ask ourselves some more questions to get clarity on how to store organize these stores. So we could ask, what is the API actually being used for? We could ask, what state is involved? And we ask those questions, we know that the first input is being used to make geolocation requests, while the second is dealing more so specifically with the restaurants that match that term. Yes, they are the nearby restaurants, but that's more tangential. So there is location involved, but that's not its primary focus. So in this case, we could store organize these into their own geolocation and restaurants stores. So as we know, the restaurant store is requesting that list of relevant restaurants, and it's relying on geolocation data. So this means we need to use data from the geolocation store inside of the restaurant store. Does this completely ruin our approach to separating our stores like this? Well, no, it actually doesn't, because we can make use of what we can call nested stores. So in this circumstance, we could be importing inside of the restaurant store the geolocation store and then just using that inside of it here. So we're still creating that separation of logical concerns and able to use them within each other as necessary. So some key takeaways from store organizing are that we are grouping related data into their own stores by logical concern. We can also organize stores by the features within our app. We don't necessarily assume that a store should be created around one specific API or library. And we can cross-share state, actions, and getters via the nested stores that we just saw. So next up on the agenda is how do we access state? Obviously, I mentioned that we're in a world that is more freeing, less prescriptive, so we have more options for accessing that state. We're not forced into accessing it in a very specific way. So one approach is if we are within a store itself, we have access to state properties in our actions and getters. So we could say, for example, this.user, and we can say this because we are in an option store. Now, looking at still in an option store, if we are in a getter, we're not going to say this.user in this case. We're actually going to be passing in the state itself for the getter to be able to access it. Now, on the other hand, in a setup store, for both actions and getters, we access a state property directly, just as we would within the setup function in a component using the composition API. So we don't use this. In this example, since the state property is a ref, it's actually written city.value. And of course, remember, we need to be returning anything that we want accessible outside of the store. So now what about accessing a store's state from inside a component? There are a few ways to do this, the most common of which is to import the store into the Vue component and then invoke the useStore function. And then this lets us read and write to state using dot notation to access the state property on the store. However, so this is, of course works, and for simple implementations, it's good enough. But using dot notation like this can become tedious and burdensome if we're using it for a lot of different state properties, and it can kind of get just unnecessarily verbose. So one way we can make it a little more developer-friendly is by destructuring properties from the stores so that we don't have to write the full store name every time that we're accessing that state. So we might think that we would do it like this, but this is a warning that this will actually break the reactivity. So just like in Vue 3, we can't destructure props unless we use a helper method called toRefs. In Pinia, we can't destructure state properties unless we are using the Pinia helper called store toRefs. And this will keep that reactivity intact for us. So to then make use of that, we could, for example, say user favorites and then push onto that state within the component here. OK, now let's look at working with state using vModel. So we can use vModel to bind something like our input here to the Pinia state so that our template is always staying in sync with that store, and then everything is reacting accordingly. So key takeaways for accessing state with Pinia. So in an option store, we can and will use this unless we're inside of a getter. And then we would pass in the state itself to that getter. In a setup store, we access state properties directly without using this. In a component, we can destructure props with store toRefs. And we can use vModel to bind the value in our component to our store state. All right, so just like accessing state is less prescriptive with Pinia, so too is the process of mutating our state. So if we compare this to the old paradigm of Vuex, when we used Vuex, we were essentially dispatching an action, and that action was then committing a mutation. That mutation would essentially click forward our state to its new state, and then in this case, maybe we're adding an element to that state's array, and if we wanted to get maybe a filtered version of that, we could use our getter to do that. And this was the paradigm, this was the approach, and this was the recommended best practice for doing so. But of course, with Pinia, we no longer have those mutations. Those are gone. We just have something more like this, but just know that this is actually only in one of the options available to us. We don't necessarily even have to follow this exact same paradigm. So we're going to look at a few different ways that we can achieve this. So the most common way to mutate state using Pinia is to trigger an action in the store that causes the state to be changed. So in this example, clicking the Add to Favorites button triggers the Add to Favorites action in the Favorites store. And some people might be surprised that this is not the only way to change state within Pinia. We could also change state directly by assigning a new value to the state property, for example. So here, we have a watcher on the city value. And if the user deletes the city, then we clear out those state properties directly so the user can start a new search. And notice we're doing that kind of line by line. An alternative, another way to achieve this, is by mutating the state with the patch method. So this allows us to apply multiple changes at once to the store state. So here, notice how we're passing an object with the updated state properties inside of it. And because we're using patch, it comes with some added benefits. So some of those include we're only creating a single entry in our DevTools in terms of that state mutation. instead of a line-by-line one for each of those. And in terms of maybe collaboration and how to be getting clarity on what mutations you have programmed in your application, you could, for example, run a search for patch in your project and find those if you're using them regularly in a predictable way. Something useful to note about patch is that it can take an object or a function as its parameter. So for example, if our state property were an array, we could use array methods to update that state. Maybe we're splicing it or popping something from it. And yeah, so we can achieve a little more complexity when we're mutating the state by using this function like so. So conveniently, Pinia also has a reset helper method, so we can reset the store's entire state to its initial value. So in this example, we're saying this.reset. This is going to, just like you would assume, reset the store's entire state. Notice how we are in an options API, so we're using this, and we can only use the reset in an options API, in an options store. We could also use call reset from within a component. So for example, the user clicks a logout button, and then we're resetting the entire auth store. We could also use it in the router file. For example, maybe here we're saying whenever the user navigates back to the home page, we want to clear out the previous search. As I mentioned before, the reset method is not available with the setup stores. And that's because the reset method relies on the state function to create a fresh state. So it's replacing the store.state with a new one, but we don't have access to that state function in the setup store, so we can't use it as such. But there's a workaround. We could just make our own custom reset action that maybe looks something like this instead, and then call that where and when we need it. Now, when it comes to mutating state, Pinia also offers a helpful method that we can use to get very detailed information about our actions, and this is the onAction method. And as you can see here in kind of the API available to us, this method has a number of hooks we can use to perform some logic when a certain action happens. And a note, we can pass in state as a second parameter if we need it. So here in this simple example, we are going to log just some information about what action happened, and then the arguments, so the parameters that were associated with it. So if we check this out in the browser with this login, we see the name of the action and the arguments associated with it. And with that, that essentially takes me to the end of my time. I actually went a few minutes over, but this is essentially the preview of our course that's coming out in a few weeks called Pinia Proven Patterns. And we go into further depth. We explore the example app that we're looking at here in further depth. We talk about patterns for Pinia creation and what that looks like, creating the global ones and the store-specific ones. And we also have a whole Pinia path. So we have Pinia fundamentals. That's a little more of the essentials that come before the nuance that we looked at today. We have a Q&A with Eduardo about Pinia, and we're actually just in the editing phase of a course that features Eduardo, where he's talking about 5 elegant ways to use the Pinia library so that you can really masterfully use it and understand kind of the caveats and considerations to be making when you're using it in these elegant fashions. And all of these courses are in a collection of other stuff. So we have Nux content, we have full stack content with Firebase coming down the pipeline. We have courses on how to build composables on Tailwind and all sorts of things. So we have an entire platform for you to take advantage of, again, to elevate your code, whether you join us as an individual or join as a team and have that learning experience and growth together. So we do have a promotion right now where y'all can either get 50% off an individual or a team subscription. So if you're interested in that, definitely come back to our booth behind here and talk to me about that. And we also have the Pinia cheat sheets for you. So make sure you get those while you're here. And on our website, we have a bunch of other cheat sheets for Nuxt, for Vue Router, for a bunch of different topics. So appreciate your time and attention, and I hope you enjoy the rest of the conference.